Hello, folks. I think we're going to put in a little bit of time today on the vectorization backend. We're still going to do more stuff on Tiny, either tomorrow or early next week. I think, though, I want to do a little bit on vectorization at the moment. I got a couple meetings that might get slotted in later today as well. We shall see. But for now, this is what we're going to work on. Yeah, we're fine here. So right. I think where we left this off. Fix our drivers first. Hey, Harris. That was good. I got some rest in. It's one of those things where getting a little rest only kind of told me, like, yeah, I'm actually a lot more tired than that, and I probably just need to take a mini vacation at some point soon. But I figure I can wait until after NeurIPS and all the conference stuff comes out, and plus there are a couple of things I need to get done in the next week anyways. No big deal. Welcome, Jess. Okay, so right, I remember we have this implemented, but it hangs, right? Let's see if I did this in a way that makes any sense at all. So I currently have this buff percent num buffers. Block size is going to be the number of m's divided by the number of buffers. Two buffers in both spots, okay. Create m's, yeah, with two buffers, cool. Gonna do a little bit of work on vectorization. I'm pleased to report I did not completely stuff myself yesterday, because I got up super late. I slept a bunch, and well, super late being 8:30, but still. And I didn't have as much time as I would have liked before breakfast. So instead of doing a 10K or even a 5K, I just did a 1 mile test. So it's like a 1 mile warm up and like a 1 mile max effort. and I don't actually know exactly how long the road is here. It's at least a mile, so I did something like a 6:30, maybe a little better. Was quite happy with that. Yeah, double buffering stuff, Jess. Split this into blocks, right? Buff times block size. Copy state out. It's all fine, right? The reason I'm working on this as well is no matter what happens with Tinygrad, we will need this anyways. Like, it doesn't matter if it's a torch tensor backend or something else. Is this any model execution performed locally? No, I have a box right here. I do a lot of my dev just on the same machine I'm streaming from. I pretty much have like the same type of machine as we have back there. You see all like the single GPU boxes. And then there's no point in using a 6 GPU box for dev. I mostly use those for bigger experiments. Like a 6 GPU experiment is actually quite large for the standards of what I'm working on here. Because like here, look, this is running on a 6 GPU box. Actually, this is kind of funny. The fact that this ended up sloping up. Because this is a completely stupid neural net architecture that's doing very well on Neural MMO3. But the reason I pulled this thing up is this is the 6 GPU box run, and this x-axis is in hundreds of billions of steps. You know, there's over 1.5 trillion steps worth of data here. Something like uncompressed data would probably be like 12 or 13 12 or 13 petabytes. A lot of data. How do you recommend getting into Pufferlib? Alright, yeah. Since we have some new people here from the content yesterday, let me... So, the usual advice, because this is the most common question I get asked, so I actually put a good amount of effort into just putting all of my best advice and all my best guidance in one place. If you're new, / don't know how to write good code, / want to know like how to think about science, this one. If you want specific RL advice, this one. These are interactive in the sense that they will tell you do this, do this, do this. It's not going to just be like read this and you're good, but it's a lot more condensed and a lot more like fast paced than pretty much anything else out there. You know, you can work through this pretty quick. So there you go. Is there anything... I don't think there's anything that could block and screw up here. I think it's just got to be the VEC. Right. Sure thing. Happy Black Friday. How many hours of streaming today? That is actually to be determined because I have two people, well, two clients, two like potential clients who wanted meetings, and but you know, with Thanksgiving and stuff, there was like some scheduling, whatever. So I have my email up on the other window to see if anybody books last minute. If not, if nobody books last minute, then I'm probably just gonna stream like probably 5 hours today, and see if I can get a good chunk of this done. Well, I guess now we start figuring out where it's blocking, right? Is the obvious thing. Take my watch off. Watch always gets in the way of my keyboard. Easily do 5 to 6 hours. 5 to 7. Yeah, but that's not really that much work if you think about it, right? Like a good work day, if I were working hard, I'd be cranking like 12, 14-hour days. This is kind of towards the end of a block of work where I've kind of like done as much as I can and tired myself out. And I'm kind of just like putting in, you know, more manageable 4 to 6 hour blocks here and there, trying to like. There are like a few concrete things I want to just have be fully done before I take like a longer break. The vectorization is definitely one of them. Um, the evaluation of tinygrad is another, and I say it that way because like I want to basically have no uncertainty about the remaining work in Puffer 4, and as it stands, it's either has to be like get some cool kernels out of tinygrad somehow / do something with that, or it's going to be like do CUDA graphs plus finish custom kernels plus like some other stuff. I think, yeah, so I want to have all the uncertainty out of this before I finish this block of work and take some time off. How much GPU do you recommend locally on a dev workstation? How much GPU do you recommend locally? I just have a 4090. Is that 4090 on this box? Yeah, 4090 on this box. If I were to get this now, I'd put a 5090 in it. 9950X. I mean, the one vice I have is when I'm tired, I end up playing games, so it's like, yay, dual purpose. The only saving grace I have is I don't have Windows on this machine at all. So at least most of the really addicting stuff I can't even download. I'll pull this up actually. Just this is what I've been doing lately. This is awesome. And it's kind of on topic as well because, you know, I do all this work on Neural MMO. That is, one dev has just like, apparently while I was cranking Neural MMO, one dev was cranking a single player MMO with scripted AIs that follow you around. And it's really freaking cool. And there's kind of some stuff in there that makes me think about, you know, Neural MMO 3 is going to be solved at some point. What do I do for Neural MMO 4? This is obviously Linux. I don't understand the whole, like, dev on Mac thing. It's just bad. I don't know, deving on a laptop in general just feels freaking bad to me. I really like my, the setup I've got here. Honestly, the biggest thing, because for a while I would, like, not want to be at my desktop and, would want to, like, go dev on the couch with my laptop until I got myself a proper chair. If you're in an office chair, you'll basically just never want to be in it. With something like this is just, like, pretty much every bit as comfortable as just being on a sofa all day. Okay, so what the heck happened here? I gotta figure out where this thing is hanging. So this thing, obs action. So it actually did a couple cycles of this. Oh, maybe there is a race condition. Hang on. I gotta go through the way that I did all this logic again. So this is, for folks who have not seen me work on this before, the purpose of this thing, this is a C vectorization backend for our custom RL environments. So the idea is you run a bunch of threads. Maybe each thread is going to, like, handle processing of environments, kind of just as they're available. But it's all done in, like, shared memory with no redundant copies. And the really key thing that I'm doing now, so I have a version of this in Python that's very, very low overhead for Python. This will be a little bit faster, but then the key thing about this is that I'm going to buffer the CUDA transfers. So the idea is by the time that you need a new set of observations, not only is it already going to be computed, but it's already going to be moved onto the GPU for you. And that's the thing that makes it substantially more complicated to do this correctly. But this is going to eliminate, like, one of the biggest sources of overhead in RL in general, I'd say. And it's one of the key things that, like, makes people try to put environments on GPU even when it's, like, obviously wrong. So, yeah. What chair do I have? I mean, this is just like a recliner, man. This is like a full recliner. It's not an office chair. And if you think that's bad for your back, then you gotta deadlift more. Like, comfy chair plus stay in shape. Way, way, way better than, like, ergonomic whatever the hell plus not do anything. Alright, so the logic for this thing, this is the worker thread. Yeah, it's funny, actually. One of these is cheaper than a good office chair as well. Isn't that nuts? Alright, so, we've got this threaded step. So this thing is going to wait for work. How many of these did we get? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Hmm. Let's do this. I really like that I don't have to rebuild this. So this entire thing is just a DLL. So that script, you see that builds, it runs instantly because it's just building a tiny little CDLL. And then the heavy thing doesn't actually need to be rebuilt. Okay, so look at this. We have all this stepping. 3,000, 4,000. They all print out of order, which is fine. this is all the way. Yeah, it looks like this actually gets through a few cycles. Let's actually check this. We have index. No, I don't actually know which one this is. Okay. Is there a better way of debugging where exactly this is blocking? I don't think so. I think I just sort of need to look at the way that this works and figure out the possible deadlock spots. Okay, so you're gonna call, you call receive, play, do this, right? You're gonna call vec receive, and then you call vec send, right? Yeah, so you call vec receive, vec send. So what's receive going to do? Receive is going to do... Go check reset. I think I did reset kind of hacky. Yeah, so reset just does... Well, this shouldn't be async. This one we want to block. Okay. Ooh, okay, that actually got us something quite different. Actions ready. I was ready. We got actions ready twice, which is jank. Receive. The multi-threaded. Use the red sanitizer. If that exists, then yes. This is not something I've had to do before. That might be surprising, but like, I wrote Python for 10 years, and threads in Python are worthless, so I did a ton of multiprocessing, and basically no threading. Is that just in like every compiler, or is this something separate? Oh, it's in Clang. Ooh. Fsanitize equals thread. How does this work with the DLL? If I compile the DLL with this, and then I import it from something else, I didn't realize this was built in. I used the address sanitizer. I didn't realize it also had thread sanitizer. That's cool. Scripts build back. Yeah. Okay, so that's gonna break because... Well, we can just use this as an excuse to write a test for this thing, right? Yeah, it's kind of funny, Vlad. I'm not trained as a systems dev. Like, despite all the low-level stuff I do around here and how, like, RL's getting super fast, like, I'm a researcher. I wrote Python for 10 years, and I just kind of, like, went more and more and more towards your end side over time. Been learning a lot of stuff lately, but there are definitely gaps. To be fair, the thing that put me off of systems in the first place was all my systems courses in undergrad. They didn't tell us that any form of sanitizer existed at all. Um, yeah, it was a mess. Oh, it is binding.h. Okay. Yeah, so I think that all we need to do here vec reset. All right, so now we're going to receive buff to star. And then actions for, okay, action and free. Okay, so we just essentially force this thing to be, I think we do have access to this, so I think we can just force this to be random actions. CUDA runtime not found. Lovely. Yeah, you just need this include, right? This. Cool. What are you working on today? We're working on the vectorization for a bit. This is test binding. Should it not be test DLL? Oh. Okay. Do this. Create environments, rec reset, rec step, rec send. Cool. You mean to use rec. Incomplete type. Do I need to test this through the DLL for some reason? Is there any reason I need to do it that way? Kinda isn't, right? Scripts. DLL test. Or just binding. Okay. That's better. There's no reason we need to do this through the bloody DLL every time, right? See? Okay, so it can't find the CUDA stuff. Oh. Does this have to be shared then? The way I have this, it has to be shared. Yeah, that's why I had it this way. Okay. Hey, Convert. Welcome. Oh yeah, I need to buy a couple things. Couple small things. Tinygrad doesn't have $20,000 off for servers or anything today. I say. Any new PCs? Yeah. They have them on customs or they just have them on pre-builts? Nah, they just have them on laptops and pre-builts. It's actually kind of funny. I probably will get one of their laptops next time just because of how bad Razer is just screwed up on my current one. But I don't really use a laptop at all, so my current one. Any good pre-builts? They usually skimp on at least something. I usually just go grab their custom ones and put what I need. Yeah, I'm not building my own stuff, man. I've built enough PCs in my time. It's like it's no longer worth my time to build it myself. Incomplete type env. Yeah, so this is the thing you can't do, right? Yep. I'd hope with the new stuff you're doing, there's at least some reasonable comp for that. Raise prices on boxes? I hope not. I'm thinking about grabbing an 8X5090, but I really don't want to do it until I see the benchmark on Puffer 4 and like confirm that it's actually going to be useful, right? It was a $50,000 server. I don't want to get it if it's not going to be like genuinely awesome. And I wouldn't mind getting like a bunch more of the single GPU boxes as well if I can get them at a decent price. So we can have just more contributors doing stuff. Put some of the the revenue back into Puffer machines probably early next year. Okay, so this is going to be actions, right? Actually, I don't know how to do this without torch. Hang on one sec. And then we'll get thread sanitizer and we'll have a standalone test and things will be good. I do not want to launch a freaking kernel. That's obnoxious. Yeah, because I don't want to have to do... that's annoying. I suppose I don't need, yeah, there you go. CUDA mem set. Better and cleaner way for non-zero values. Why is it doing this? I think this is fine. Yeah, I think I can just set this here. Like, I just need something that's gonna cause the kernel to have to sync, right? This is gonna require me to include... Yeah, this is gonna require me to include the CUDA runtime, though. Let's do it this way and we'll see. Wait, what? Define symbol. Oh, you know why? Hang on. I know why. I just need to compile both of them with it. Try this. Check failed. Okay, what is this? Okay. Operation not permitted. I'm in a container. Oh gosh, are you kidding me? Do this? Oh, that's annoying. Gotta love Docker. We'll have to do it without it. I do not want to have to remake the container. Actually, but thread sanitizer would be so nice to have. Oh, no, this is way better. Yeah, I need this. This will just save a ton of time. There. That seems really stupid, but we'll try it. And sometimes I hate that we have to use Docker for everything. Like the least of the evils, though. So technically, Joseph will remember that. To the host Alec. Okay. It should be this. I suppose I could commit this stuff and just try this not in a Docker. Would work, right? I already have it set up on tiny boxes. Should we just do that? Let's just do that, because otherwise this is just so dumb. Screw Docker, man. Then I won't just be sitting here doing fighting Docker. I'll actually be able to fight the bug. Man. Yeah, this one is free. I will watch the Ilya interview on stream at some point, Jess, when I get a chance. Oh, we have a bunch of people on YouTube at the moment. Welcome, everybody. If you're new around here, I stream all my dev. It's all open source. We are currently working on a high-performance vectorization backend for the next version of Puffer 4. This is going to do a bunch of stuff that's going to make pretty much all of the GPU CPU transfer overhead go away magically. But there's a bunch of threading and I'm tracking down some data races. If you're interested in my stuff though, it's all here, Puffer AI. You can help me out for free by starring the repo. And if you want to get involved with all this stuff, Discord's right here. Most of these environments are built by contributors. And a lot of these end up being really useful in research as well. Back to dev. Okay, so now we're on tiny boxes. And the reason I'm doing this is because the tiny boxes don't work on, they're not using Dockers. So this should just be a quick way for me to get the address sanitizer to run, or the thread sanitizer rather to run. Hey Tim, welcome. Yeah, and if we can figure this out, so pretty much I have this working with one buffer. But what I want to do is I want to make it so that when you compute your observations and actions, right, your model only goes through the environments like in chunks. And then while you're processing this chunk over here, then this chunk over here is still computing observations, which is already how Pufferlib works. But the difference is that now instead of computing observations on CPU, it's also going to move them to the GPU for you in the background, because that is the main source of overhead right now. Pretty much in all of the RL we're doing. There are a few other like low-level sources of overhead that I am fairly confident I'm going to be able to remove in this next version. This is the big one, and this combined with CUDA kernel fusion, combined with maybe CUDA graph should get us 10 million steps per second training. That's the goal. I don't want to launch this before we have 10 mil steps per second. Pufferlib extensions breakout.c. Apparently I forgot to commit this. Okay, so now we no longer have sanitizer errors. Why do we have this? Ooh, apparently this test does not, apparently CUDA is not getting included in this. That's weird. Uh-huh. So CUDA does not get used anywhere in here, but this env binding DLL does. But I thought that I have, well, this is definitely, okay. Yeah, it's because the setup.py file, when I'm running this from Python, yeah, this is getting included from here. I thought I had, there's got to be some extra flag. Yeah, the link args. I thought I had that. Oh, I went. Did I not have that? Let's just try that. And this goes underneath here. Yes. Okay. This is what we wanted, folks. This is exactly what we wanted. So now we have thread sanitizer. And this will tell us exactly what we're doing wrong, and we won't have to guess. That is incredibly convenient. Right of size. Interesting. So we're actually getting a data race and compute observations itself somehow, which should not be possible. I think that's a real error, though. Here. Let's see if anybody else. What was the result for TinyGrad? It's good so far for both of you guys. We're gonna do more TinyGrad stuff either tomorrow if we finish this or early next week. We're definitely doing more stuff with Tiny. You know, I didn't get enough time yesterday in to see if I'm like fully on board or not yet, but what I saw I liked. I mean, so far the impression is definitely better than Jack's. But we'll see whether it gives you the same low-level flexibility as Torch does. Like, Torch's low-level stuff is terrible, but at least it exists, right? Alright, so... how on earth could this possibly be touching the same environments, right? Because you do atomic fetch, add, explicit. Let me go check what the hell is going on. There's some weird construction or something. Give me 1 minute, and I gotta get coffee anyways. Oh, and yeah, let's make it 3 or 4 minutes. I'll also get my first bench set in for the day. 9 reps. Failed number 10. 10 would have been tied PB. And that PB was from when I was 15 pounds heavier than I am now. So, 210 for 9 ain't bad. I only weigh 170 at the moment. I think I PR'd the mile this morning as well. It might have been like an exact tie with my old one. I'm not quite sure. Hey, David. Alright, let's get back to the real heavy lifting here. Hey, Ratswag, welcome. So I don't understand how there could possibly be a data race on this of all places. 5'9", Jess. Plum average. 210 on bench? Yeah. 210 for 9. My best single ever is a 265. That's when I weighed like 187 though. That was much heavier. I'm not doing like heavy triples, doubles, and singles at the moment though. Pepe, I've been saying that I will watch the Ilya and Dorkesh podcast on stream at some point. I haven't gotten around to it yet. That's disgusting. I feel like Fred from, Scooby-Doo. Oh, I bench 210. It's like, alright, it's okay. You'll get there one day. Hello, welcome. I'm definitely still out of breath from the 1 mile this morning. I gotta so I did something kind of stupid. This is a $100 phone. I got this thing as a temporary thing because I ordered a minimal phone. Figured I'd try it and see if I like it. But I have not actually bothered figuring out how to get Strava and everything set up. So I have not synchronized this to my watch data from running for the last 2 months. So I actually don't know how good any of the PRs I have set are until I go and do that. But I know I've gotten several of them. He doesn't say much. I will be the judge of that, Tim. Is there anything that would make this? I guess technically screwing up the work index could make this, atomic load explicit. But this just reads to it. So wait, how on earth can this possibly be data race? Still get mad at Dwarkesh? Of course I will. From what I've seen, I don't exactly have a high opinion of him. That's why I tweeted, Ilya's literally the only guest that he could get that would make me watch his podcast. Is it possible? Hang on. What does this say precisely? Create environments. Oh, wait. It's in create environments. It's wrong. Wait, no. Created by main thread. Right of size 1 at this address. Right of size 1. Is it telling me that it can get all the way around? Huh. Does that make any sense? Is this a real bug or is this the thread sanitizer being like wrong? Like I haven't used this before, so I don't actually know. Because the thing is, I'm synchronizing. The thread should be getting synchronized through CUDA. And let me go look at this manually a little bit. Because this is just counting upwards forever. Oh, this is going to skip environments. This is bad. Yeah, this is going to 100% skip environments. I didn't realize that. Yeah, okay. Is it? Yeah, it is. You can't actually have this, like, index less than end check. Okay, so we have to redesign this a little bit. This is definitely a race. Do you see why? So because, like, this less than check, this is just, like, ignores the last few increments before this syncs. But then the index is going to be wrong. Hmm. That's a problem. But this counting up forever architecture is, like, kind of nice. So let me see if I can kind of just talk through this. So what's going to happen is you get all your environments reset, right? And then you get observations submitted. And each time you submit a batch of observations, you increment this end counter, right? Not great. Not really great. I could assign them explicit chunks of work. That makes it easier to synchronize. But I think you can lose perf doing that. But isn't this like a very common architecture? This is just producer consumer, isn't it? Single producer, multiple consumer. So why does this feel off? Well, because you want this to be super low overhead, right? So I'm trying to manage this just with like one atomic index. And the problem is I well, the end index is basically, yeah, that one doesn't have to get checked very often. You do just have this work index. Yeah, this is definitely a race condition right here. If you were to fetch these both at the same time, no, it's because you need the entire block to be atomic. You'd have to lock the whole block. You'd basically have to do a more complicated locking mechanism for this, rather than relying on atomics. That feels sketchy, though. That feels sketchy. Yeah, so these atomic ops just give you like a very minimal set of things you can do without more complex locking. I'm not done testing Tiny Grad Rat Swag. I'm going to be doing that more. I'm working on our new vectorization stuff. It's going to be pretty awesome, but it's going to take some work. A dish. This is true. This is very true. I still have not read this. I've meant to. Oh yeah, this actually does get me excited about the interview because this is spot on. This is basically what I've said the whole time. And actually, this is kind of what I told Ilya like 7, 8 years ago now. When he asked me like what I thought about language models, it's like, yeah, I think they're going to work really well, but they're not going to solve everything. And you're going to need, well, in my case, I thought it was you're going to need learning from sim. You need RL interaction. Okay, so I can just bite the bullet here and do some more complex locking, but this loop you want to be very tight is the problem. You actually don't want to do any more complex locking in here if you can avoid it. And this is actually... So really all I need then is... If I fetch the current index and the current end... You'll never go over it, at least. Hang on, does that work? Wait, I think that this does work. Hear me out. So... If you make sure... I think I just have to change how I broadcast a little bit. So when actions are ready on CPU, I add block size to the end, and the problem only happens, I think, when this has already gone past the current end point, right? Because then you're going to miss some environments. I think that's the key problem. And then you say, hey, your actions are not ready. Cool. And then you're just going to check when the work index is greater than this start. Yeah, so this can definitely screw you over. Okay, hang on. Hang on, I have an idea. Int end. Concurrency is very difficult for me to think about for whatever reason. So what I want to do is I want to avoid incrementing index at all costs above the end, right? What about C atomic? C atomic. Flag. Fetch. XOR, fetch and. Change explicit. Well, end only gets set. End is never going to get, like, smaller on you. The problem is, and we don't actually care if end gets incremented. The problem is just index, right? We don't ever want index to go above the end. Hang on. The heck is this? Atomic fetch add plus compare. Oh, that's interesting. Why the hell didn't I think of that? That never breaks, right? Isn't that, like, that's so obvious? Why the hell didn't I think of that? Is there some reason this doesn't work? This end can still go up here, right? Atomic fetch sub implicit 1. Yeah, like this, no? And... oh, this is a different one now, isn't it? Cool. Okay, so let me think about this now. Can this ever result in you processing this index twice? It can't, right? Because you only ever... so what happens if this gets triggered a whole bunch of times, right? Let's say you add up, you go way above the index. this never happens then, and they all get subbed out. And if end goes above on like one of the threads, then you'll process out of order. You can end up processing out of order. Slightly. You can end up processing slightly out of order, I believe. Is that a problem? Up to num threads out of order? I don't think so. I don't see why it would be. I think this is fine. And this is very, very low overhead. This op. Okay. Let me compile this without, well, let me see this. This previous write, vex send. You don't track. I don't think it matters here. Because it's only, hang on, does this? Oh, actually there is still a race condition here, shit. There is. So your last threads can still be processing C step, and this work index will be too high. Okay, that is annoying. I could add a completed index. Does that help if I just add a completed index? That does it, doesn't it? Let me see what's going on in my thing here. One sec, guys. All right, I thought about how we're gonna do this. Nah, they're just doing a little bit of maintenance. Invert. And apparently they left a pair of pliers up there. So all we need to do, I think, is add one more atomic, which is going to be completed index. And I think all I have to do is this. Atomic add explicit. We did like this, right? And then instead of checking the work index, yeah, see, this is, I even knew it right here. How many NERPs have you attended? How's the vibe changed there throughout the years? I don't know off the top of my head. Somewhere between 4 and 7, I think. First year was 2017, which was back when it was still called NIPS. Other way of not having to worry about it is to use code Joseph wrote for you. I mean, the theme around here is I kind of do all the ridiculous, painful, low-level crap. And then you all just get to do chill, low-level game dev. And that actually somehow turns into real awesome research progress, which is pretty awesome that it works that way. It's pretty cool. Why doesn't autotune work? The reason that autotune doesn't work, Jess, is because our M's got so fast that, like, I haven't bothered with that thing in a long time, because you no longer need to run autotune on anything native, because everything is just fast. Ideas for a strongly tree-like structured env. There are a lot of things you can come up with that. It's difficult to come up with meaningful ones, because, like, technically everything is an exploration tree. I'm kind of fresh out of intelligent thoughts, honestly. I'm kind of just coasting on the last bit of this dev before the holidays. I just have, like, a few more things that I want solid on Puffer 4, and a few more things to get done for clients. Not atomic add explicit. So far, Chungli, yes. I did not finish it yesterday. I thought I was going to have all day. And then my family informed me in the morning that Thanksgiving celebrations were to be held at 2 p.m. instead of, 5, 6, 7. So I'm going to do another stream on that. Maybe tomorrow. If I happen to, by some miracle, get all the vectorization done today, I'll do TinyGrad tomorrow. If not, then it'll be once this is done on, like, Monday or Tuesday or something like that. Comic add. Comic fetch. Should be fetch. Use variable work index. Yeah, we don't need this here anymore. Okay. Read size of 4 and step. Previous write. C reset. I'm a little sketched out by this because this is a synchronous operation. So yeah, this entire thing is synchronous. It says it was previously written by the main thread in reset. How is this a data race? You always call vec reset here before you call receiver send. Oops. When does it start reading? Hang on. Maybe it is off. Go look. Geez, everybody watching stream on Black Friday, welcome everybody. To all the new folks here. That is not including anybody on X, 27 people. So if you're interested in RL, whether you're already in the space or you're interested in getting involved, this is all free and open source work. The vast majority of it does not require you to wade through low-level hell, though you're free to dig into that if you want to learn stuff there as well. It's all on puffer.ai. Want to help me for absolutely free? Feed the puff for a star. It actually helps me way more than you'd expect and lets me spend more of my time on this rather than like client stuff, business, whatever. Now, there's technically a company here as well, even though I spend all my time on research. Discord's where all the dev happens, and I also post educational stuff on X. And if you're looking to get into RL, the articles on my tab here are where you get started. Has all my best advice. Back to dev. Okay, so we've fixed a couple of these issues. Now, when does this thing get started? It gets started as soon as... I mean, it gets locked right here, doesn't it? So, wake cond. When do I wake the threads up? The thread manager wakes these threads up, right? This is when you create them. So it initializes the wait cond. So then these threads are all created. I'm a little confused though as to where wait, does this not get broadcasted at all? It only gets broadcasted in the C thread manager. Oh, okay, I'm dumb. Yeah. Wait. No, because then this only broadcasts when actions ready on GPU is true. Right? Threading actions ready on GPU. Ready on. Where do we set this? It's on vec reset, right? So you set obs ready on CPU to true. Actions ready only gets called when you call vec send, no? Okay, so let's actually just see when everything is happening here, right? I think I have some idea now. So let's do a quick printf worker on wake. I don't have my autocomplete here, so give me if I mess things up. Woke up. Hello, Hyper. Welcome. Okay, so worker wakes up here. So then we're gonna figure out actions ready, obs ready. Okay, perfect. So we already have these in place. And then we're gonna call the bottom, we're gonna say print finished creating n. Okay. Anything resonated? Everybody keeps asking me that. I've said I'm going to watch that podcast on stream. I have not watched it yet. Probably not going to be today because I'm actually getting good stuff done on this. But we are going to watch that on stream. So, and then I'll probably post the VOD of that on YouTube. I think I'm allowed to do that, right? I'm super fast. Data transfer. Yeah, so this should actually fix that just completely. Now, obviously, you can't get above. We're going to have a bandwidth test that tells you exactly how many gigs a second you can have of OBS. But, like, we should be well under control with this. There are a couple sort of weird side effects, I think. Shouldn't be too bad, though. Especially with the other optimizations that we have going for us. Alright, so we want to do break 57. Okay. So, new thread. All the workers are waiting on waking up. Thread manager is initialized. Finish creating M's. Nothing can possibly be racing yet because everything is just waiting. And I think, actually, we're going to do one other thing here. Do I have any threads that are just like... There should be one thread that's spinning, no? Thread manager initialized. I thought I have one thread that I just have busy waiting. I do have one, don't I? Why don't I see one thread like spinning? Oh, I do, right here, 37. Yeah, 37%. Wait, but this is the display service. This is not even my thread. Oh, because I'm in GDB. Duh. Wait, no, GDB shouldn't stop threads, right? Yeah, GDB shouldn't stop threads. Okay, I actually have no idea why this thing is not taking any compute, but whatever. We'll not question that for now. Okay, now we call vec reset. And no, nothing gets printed because this is a fully synchronous function. Now we call vec receive on the buffers. And nothing should happen again because the only thing that vec receive does synchronizes this stream on CPU, and it sets this to false. Okay, ob's ready, and I don't think this flag gets used at all, right? It should not get used at all. On. Yeah, so this only gets set by this here. Cool. Next one is to update Discord. Takes 2 seconds, Jess. Just dpackage-i on the binary it downloads. It's a little annoying that it's not automated, but... now this should print a bunch of stuff. Okay, so we called vec send. PyTorch PR get merged. Let me get rid of this bot real quick. I have not checked it. And I don't want to break momentum here actually because it's complicated. Okay, so what do we get? We get workers woke up, actions ready on CPU. Right, so this, because we call vec send initiates, an asynchronous copy. Right? They're ready on the GPU, yes. And then the manager thread this waits until this CUDA transfer is done, and now obs are ready on the CPU, not just the GPU, right? And then all the workers are going to wake up. So what is this race? This is saying that we have a race vec send Oh, did I do this bad? I think I did it bad. Wait, why is this a problem? Is the thread sanitizer just expecting me to sync everything? Or is it too aggressive? Or do I have something wrong here? Let me see. So here, Beck send marks actions ready on GPU as true. And then this thing is gonna poll. Let me go check on this. I want to see if this is just the sanitizer being pedantic. I think either way, it's probably will be good to adjust this. Oops. Any advice for noobs starting out in RL? Entire guide of it, my guy. These two articles, and feed the puffer a star. All free. And all the resources that this points you to are free. Okay, so let me just go double check. I mean, there's no point, not really a point in doing this. I think I can just do atomic flag. Atomic flag. Let's do C atomic flag. Oh, it's just atomic flag. Cool. Atomic flag star. Atomic flag. Atomic flag. How do you check this thing? Just atomic load. Flag clear. This, right? Atomic flag. Okay. This atomic flag test and set buffer. Then this will not have anything possible to complain about. Atomic flag test set. Atomic flag flag set. And even if this is the thread sanitizer being pedantic, I'd like to pass the thread sanitizer because that's kind of a useful tool to have. And now I get to do, well, not atomic load. Atomic flag clear. Atomic flag star. Cool. And okay, so I think this is going to be what we want. Atomic load. This needs an ampersand. What was it 123? Atomic flag clear. Address must be pointer. Atomic flag. Yeah, this will just do minimal. Do not have this. Trying to set it. Like that. Member reference type is not a pointer. Yeah, I just made the same error a bunch of times. No worries. Those should all end up, like, those will all get cleaned up anyways. Flag. Yes. Oh. Are you kidding me? That's super stupid. Why the hell is it like this? That's so annoying. Go away, AI. Oh, okay, it's a low-level thing. Fine, we just want atomic bool. But then why is there not a C atomic... Why is there not an atomic bool? Oh, there is. But wait, there's not... Oh, you dummy. It's just atomic bool instead of atomic flag. Alright, that's easy. Does Puffer have an easy way to use image obs? Yes. You have to create the image arrays manually in step. Well, it depends. Like, if you have a custom environment, then your custom environment has to return image obs, right? If you're using an existing third-party environment, then it's already going to return image obs, and that's just an array. Like, images are just arrays. So the reason that we don't use image obs usually is because they're slow to compute and they're big. But there's nothing preventing you from using them, right? There are like plenty of M's that have them. The only advice I can give you on that is, ideally, if you have to use image obs, like usually you downsample them, do the downsampling operation like as close to the env as you possibly can, so that you're not like manipulating giant chunks of memory on the main thread. Be surprised how often people mess that up. Discord. Fish. Oh, cool. Thanks, Jess. Oh, I see. Your content. Oh, you're also, you do technical content? Hang on. Oh, okay, cool. Heh. That's fun. This one's actually kind of relevant. Yo, Green, so RL is really, really bad at mazes. Like, and if you think about it and you know a little bit about the field, it's kind of obvious why. But we do have the state-of-the-art maze agent by, like, a factor of 10 in Pufferlib, which actually is way smaller of a maze than what you even have here. Like, again, it's a really, really bad problem for RL. But, that environment is included and you can play with it. Somebody just PR'd TCG stuff as well, which is kind of cool. Cool. Not Atomic Set, what was it? Atomic Store. Alright, this now builds. Nice. We get farther this time, I believe, right? Okay, we make some M's. Reset some M's. Interesting. We are not getting any... We're not getting any thread errors now. But we are hanging. Huh. So we fixed some stuff, apparently. That's cool. This. Ooh, look at this. That's a cool PR. I like that. Ever so slightly faster as far as ELO is concerned. That's good. Yeah, the architecture thing is kind of funny, Jess, because, like, even with a completely terrible architecture, this is neural MMO. Look at this. This is without the conv encoder. This is with just, like, a flat linear layer as the encoder, even though you have categorical data in there. No retuning of hypers either. Right, let's see what this gives us when we just run like this. Alright, so now we have some thread sanitizer. So we are saying that there is a write in C step, previously in C reset. Interesting. Oops. Create our M's. Reset our M's. Buffer. Steve. Send. Worker woke up. Steve. Send. Steve. Okay, so let's get some more debugging in here. F. Save. Waiting on obs. View obs. GPU. We're just gonna like add some stuff in here, right? And oh, and let me make sure I don't have any important emails. Speak is better, perfect. So I don't have any emails last minute. Very good. And Twitter has reminded me third bench press set time. Take a couple minutes. I get my coffee refill as well. As it is, what time? Well, 2 p.m. I should be able to get some stuff done. I have it, and if there are no meetings, I got 3 hours more to do this. Okay. So, get rid of this. We don't need this. This one's here. We also want to do vex send. Literally nothing blocks in send. So trained a small, stupid maze solving model with Puffer. That's cool. Yeah, it was one of the things we did in our demo, right? For where's the maze agent? We had a really good maze agent. The 3.0 article. Yeah, this is our maze agent. And if you know the literature in RL at all, like, this is Soda by an order of magnitude. Tiny bit better. I mean, we didn't have to do very much with it. Yo, Kevin, how's it going? Were you actually benching live? Yeah, I mean, I do all my sets in the background throughout the day. Have you not noticed? That's kind of one of the perks of working in a gym, is I get to just do my sets throughout the day. Hey, Nalacha. Welcome. How is the compute startup going? Nalacha does what's the URL, man? I'd be using it, but I haven't used any cloud compute in a while since I have all these servers. What? Ah, gotcha. Where are you? There it is, cloudy. Nalacha builds this. It's pretty cool. So you all can go check that out if you're looking for cloud compute. Actually, this thing has a ton of backends, right? Does it aggregate? Does it include Vast in the aggregations right now? This is pretty solid if it does for that. No? Ah, yeah. So Vast is like the super cheap one for single nodes that I usually recommend my users use. The stuff is just so cheap. I mean, we have all of our own compute now for Puffer, pretty much. Unreliable network speeds. Yeah, I noticed that. But the thing is, it kind of doesn't matter a lot of the time for single node stuff. Like, there's basically no point in going to multi-node with how fast a lot of our RL is. If you'd ever like to see 1.5 trillion steps worth of data on one plot, here you go. X-axis and hundreds of billions of steps. Like, I don't know, 12, 13 petabytes uncompressed of observations. And this just ran in, this is like on one tiny box, 6 GPU server. You definitely don't need cube for this, man. It's way too heavy. I just have, like, here. If you look behind me, you can see all of them, right? There's single GPU boxes, and then there are a couple multi-GPU boxes above them. Actually, the single GPU ones are mostly available to contributors as well. But they all just have the same Docker container on them, so it's super fast to, like, nuke and install. You just have to go grab whatever the latest Docker is. You don't have to mess with host packages per machine. And that's pretty much it. And then you just SSH to the nodes and use Tailscale for auth. Pretty simple. I also only support containers, and my new stuff needs VMs. What do you need VMs for? Shared storage next week, 4 gigabytes of compute. That's cool. Yeah, that stuff all makes sense in LLM world. With RL, you kind of just want... I mean, it's not even like an appreciable market. It's mostly, the users are mostly like hobbyists or, individuals playing around with stuff. Some companies use it as well. But RL is not very compute intensive. Well, at least not anymore. Our goal for Puffer 4 is 10 million steps per second on one GPU. So you can imagine that with those speeds, even a single GPU takes you very far. I think this thing works. Actually, I didn't want to run it this way. I wanted to run it... Oh, I do. I offer containers on a distributed file system and handle a bunch of syncing and caching. Can't do Docker in Docker without VMs, bare metal, or Kubernetes. Yeah, that sounds like a pain. Containers on distributed. Oh, okay, yeah, so Vast, you have the same Docker in Docker. On Vast, I say. I hope it's going well, man. That is, I mean, just good infrastructure is always so useful and so underappreciated, but ultimately it doesn't matter if it's not appreciated in a startup as long as you have companies using it and paying for it. Okay, Vec is waiting. Vec. What did I do there? Laying the groundwork. Yeah, exactly. Okay, let's try that again. And okay, there we go. We get obs. And it's going to tell us that everybody woke up, right? Actions are ready on CPU. Then it's going to say that we got the obs on GPU. Okay, so this is where we're stuck, right? So we are waiting, obs ready on CPU. We're waiting here. And a worker waiting on waiting. Let's see what this looks like. So we created all our environments. We called reset. We called receive. And everybody wakes up. Wait, why does everybody wake up? And this should get back up to waiting on wake, shouldn't it? Oh, wait, is this off by 1? Hang on. I think I have off by 1. So if the index is less than end, otherwise, yeah, this sub. Okay, I have an off by 1 here somehow. Let me think about this. It's gonna take me a second. Only off by 1 from the infinite's off by 2. All right, let me see how we're supposed to do this. So index is less than end. Yeah, so this is gonna loop infinitely, you see? But while index less than end. No, isn't this fine? Hang on. So if you have index equal end minus 1, right? Then you fetch it. Index, so this is end minus 1. You add the completed. Oh. I see. Is it just this? Because if this fetches end minus, yeah. Let's try this. Okay, so why do these workers, why do they wake up? And then why do they not get back? Right? You added to the end condition here. What? Well, that's weird. Created 1024 M's. How does that make any sense? And index is 512. What happened here? How on earth is this only going up to, you know, let's do this. And D. Let's do this. Okay. That make any sense to anybody? How the heck does this happen? Well, evidently I'm out of brain cells at the moment, so, I also only see 2 workers waking up. No, I see them all. They all wake up, okay. Oh, God. Really? How did I do that? Completely stupid. Alright, we got it. Okay, so now we reset. We receive. Send. Eh? Did I not rebuild? Make absolutely sure. Oh, I may as well put this one small ad out. Do that. Whatever. Wait instead of learner, right? Ah, yeah, that happens. But I don't know why it's still not working. Delete it. What did I mess up? Did I like not? I'm confused. Did I not recompile this correctly? No, it still doesn't work. Index equals, you fetch the, it's a fetch add less than the end. Step. Still breaks. Yes, this is wrong. The heck? Alright, so we just do this, right? Like something stupid. Okay, it's not getting compiled because I'm confused as to what's happening, but like there's no completed. Alright, so if this were looping infinitely, there's nothing else it can block on, right? Like what the hell what else can it possibly be blocking on? I'm confused. What? 8, 9, 8 through 24 is 16 indices? Oh, is this GDB just being weird? This might be GDB being weird. Well, there we go. That's it. That's why as well it was not running the thread in the background. Spec send. Exec cannot support this command. DB, where does it show the version? PTB set. Oh, okay. It's still not doing anything. Ow. It doesn't make any sense to me. Hey, Kyung. We are fighting asynchronous things. You know? Sweep is ready? Awesome. Link PR and I shall review it as soon as I figure out this one bug. Very good. Just a moment. Race conditions confusing. How are these overlapping, man? You can keep... It would be better to start sticking stuff on 4-0. It's easier. But what have you done to tower climb? Like, what did you change? Regenerating 20k maps, change some internal stuff. The 20k maps is like 2 MB. Huh? And it's still fast? Map's hard too. Good. Do you have any cool learning curves on it? Well, I guess I'll see in that PR when you do it. Yes, of course it is still fast. You say of course it was still fast, man, but like... This is the main conversation I end up having with like clients and like labs and stuff. It's like, oh, well, you did all this stuff. Is it still fast? And it's like, no, we made it 10 times slower. Every damn time. It's like, I don't know, it's the main thing that I deal with outside of like pretty much everyone who's just doing Pufferlib hobbyist and stuff like understands, but labs and companies like do not understand the importance of speed enough whatsoever. It's like, man, we can just write whatever code and the computer will run it. Hmm. And not entirely true anymore. We do have we actually have a couple pretty damn technical clients that have good engineering now, which is way, way more preferable. No, Kyung, they don't sweep ever. Yeah. I don't know. It seems crazy, but like you got to realize this is the default everywhere outside of Puffer. Like the vast majority of top publishing labs and industry projects do not even run hyperparam sweeps. And they don't even have as stable of an algorithm as we have either. So it's like, well, how do you get stuff done that way? You just, well, you don't. Yeah. Okay. Sounds good, Kyung. I have, what time is it? 2 hours, 15 minutes. Hopefully we get PRs done and bugs fixed by then. I'll be very happy if we have this work today. No, I'm baby RLer, but I read a lot. So Tim, the problem is if you're using the literature to get an impression of how to do RL, the problem is the literature is shit. Like, it's so funny because it sounds like so completely arrogant if you're not familiar with the space. Like, look at this dude, he's just like the only one who does good RL. Like, that's ridiculous. But then if you just like look at the stuff we have in Puffer and then just go to the RL poster section of any major conference and just go down the aisle, you'll just go, oh, I get it now. It was really funny. I had that happen with Spencer at RLC. It's like, it's not that I didn't believe what you were saying, right? But like, it can't possibly be like that, right? You've got to just be exaggerating, right? You're kind of an over the top guy. You got to be hamming it up somehow. And it's like, I'm not. If anything, I'm underselling it. I kind of found like the best space ever in that sense because I don't like to do the grifty sales thing, right? Where they just fucking lie through their teeth. But I like to be very over the top. And the only way that you can get those two things to go together is when you're in an area where things are just like truly done in a bafflingly stupid way. Clever ideas that might work rather than a dumb one. Yeah, exactly. Academia is very myopic. It's very myopic. Tiny grad puffer release. Jackson, stick around the next few days. If I finish this today, I'm streaming Tiny Grad tomorrow. If I finish this tomorrow, I'll stream Tiny Grad like Monday or Tuesday. The only really major complaint I have so far with Tiny is the JIT speed. The JIT speed is awful, and because you have to run the max autotune version, like equivalent, in order to make it reasonably fast. From what I've seen so far, I'm gonna have to run more thorough tests, but that's like the key thing right now. Because like I do not want puffer users to like run experiments and have a 15-second or a 30-second startup time. That is awful. And then it's even worse than that because it's, well, oh yeah, it just gets cached anyways. But if you do sweeps, it doesn't get cached. So then we have to add in like extra warm-up code so that you don't mess up the sweep profiling. It's kind of obnoxious. Is it any worse than Torch compile? No, not at all. The difference is Torch has a very good eager mode, at least. So, like, Torch eager mode is actually sometimes as fast as, like, reasonably good compiled stuff out of Jax. It's kind of funny. Like, Torch eager mode is, for whatever reason, just way faster than anybody else's eager. Even though Torch is so bloated, like, you'd expect it to be slow, and I mean, it could probably be way faster than it is, right? But still. I don't know. I don't want to ship Puffer 4 until I have 10 million step per second training, and it'll be path of least resistance to 10 million steps. Also, have we reminded folks to feed the Puffer? He's hungry. It makes me sad whenever the curve stalls out a little bit like this, you know? Keep the curve going up. Feed him stars. He likes it. It helps me a lot. It's free. Click button. Do you guys understand though why why those metrics matter? Like, let's say that I decide Tinygrad rocks, okay? Let's say that I actually just decide, you know what, Tinygrad is awesome. It's basically the same as PyTorch to implement your networks. I'm comfortable, like, just telling my users to use Tinygrad. For businesses, if this number were, like, 200, there'd just be no way in hell that I would be able to ship it. Because as soon as I go to any company who wants to use Puffer, they will bounce off it immediately when they see that I'm using like some niche, probably unsupported tensor library that'll probably be dead in a few months, right? But when you actually have a lot of traction on a project, it's more like, oh, okay, we're adopting an up-and-coming library that actually has traction and good growth and stuff like that. So that's why the stars and stuff are important. And when those metrics are not happening on their own, I have to spend more of my time on like growth and stuff like that instead of actually writing code. That's why those metrics matter. It's not about funding or anything. Like, we're not raising. And I don't think it's disingenuous either at all to just like ask my users to star the repo, right? That's not like fake growth. That's genuine growth. Just like asking the people who already use your stuff to go ahead and like show that they do. How's the work funded? Work is funded through... At this point, we're mostly doing custom sims. We also do priority service packages for a few companies. You know, we have a couple companies that we've like done work for that we circle back with occasionally. The thing that I just introduced, which I think I gotta go talk to a couple of the companies that I've done stuff for already, is because it's really difficult to keep track of the million different chats I have with all the different companies. So I think that the easiest thing is just gonna be to do this like relatively low cost sub thing. So instead of having to have a 10K a month contract with Puffer, just to be able to have like a $200 a month sub that gives everybody access to a chat in one place where it's easy for me to like stay up to date on everything. That's the latest experiment. But obviously the custom sim packages are like way more than that. And likely those will go up every version as well, because like we can take on harder and harder problems every release of Puffer. Labs you're working with? The main one at the moment is Vininsky's lab, NYU, because we have Puffer Drive. I've done a couple things with Kathy Wu's lab, just a few small things in a tutorial to her lab as well on Puffer. And there's also Forrester's lab, where I've told them that I will give them a intro tutorial on all this stuff after NeurIPS or after the holidays or whatever. I would have been able to go probably discuss in person at NeurIPS, but I'm not doing NeurIPS again. Like, it nearly killed me last year. I'm not... It took me, like, a year of training to get my health back. So, I'm not doing big conferences for a bit. Why? Near-lethal pneumonia from NeurIPS last year. Was in the hospital for 5 days. So, screw that. Did you get pneumonia? There's a strain of it that goes around, like at big events and stuff. It's also like in barracks and stuff. It's not the same type of pneumonia that you usually see in like older people. No, it's this one it gets passed directly. It's mycoplasma. And it's annoying because it's really easy to miss. So by the time I went to the hospital, I had like less than one full lung to breathe on, and I had 105 fever. So, yep. What are you working on now? I am working on the C vectorization backend. The goal of this here is, well, one, to eliminate Python overhead from Vec, but then also this is going to allow us to, I think this should let us eliminate CPU to GPU transfer overhead, which is going to be really sweet, because that is a major, major source of slowdown right now in Puffer. But we have to do a bunch of threading. To do a whole bunch of threading. Yep. This is saying that they're writing over each other, which is weird to me. What if we just, what if I just take thread sanitizer off? Put this back on. Yeah, this is going to be a very, very big perf bump if I can get it to work the way I think it should. Pretty much it. What the heck? Huh? Well, that's interesting. I messed something up here. M set. Huh? How is this possibly Vec unaligned? Heck? That makes no sense to me at all. How the heck would it allocate it unaligned? Domain randomization seems to be successful. Reach out to Spencer about using a box. He can get you set up. I don't have you on the cluster, do I? Oh, hang on. Hmm? Well, that's bizarre. Let's try this real quick. Alright, let me send you, hang on, let me send you the form. There's a one-pager just that says you will not do bad things on the cluster. And actually, I'll let you use this box that I'm on right now after I'm done with this debugging mess. Pretty soon. For cluster. Buffer cluster user agreement. And for people watching, this is basically an open offer for anybody who is doing substantial work around Puffer. You kind of just get prioritized for machine access based on what, like, the stuff that you're working on. Send this to you. I will drop this in Discord. And I just need that signed. My electricity bill must be crazy. What do you think the bill would be if I were renting these machines? Okay, that makes no bloody sense at all, right? I don't understand how this is possibly out of memory. Separate LSTM is gone. Kyung, if we manage to get Mingru to be decidedly better. But there is still going to have to be, there's still going to be two separate functions for forward and back, like in forward and eval. But there will not have to be two separate networks. Tinygrad is so far so good. I need to allocate more time to that either tomorrow if I finish this, or if I don't finish this today, then probably Monday. See if this is correct or this is bullshit. What the heck, man? Thank you, Jess. Let's not open that here. Good. I will get you some details on this. I honestly, well, the problem is that the solar panels just look awful. The main thing with them. It's like much nicer to be surrounded by corn than it is to be surrounded by solar panels. You don't have enough area just with one roof. Actually, how much even is it? I'm actually curious if it's like per box more. Oh, yeah, it's not even substantial, dude. Yeah, the power costs are not even substantial at all for these. The hardware itself costs way more than the power. Yeah, if I were running a tiny box like 24/7, it would just be a couple $1,000 a year. How the hell much? How much expensive is power in the UK that you guys keep saying that? The hell? Well, Come join us in a real country where things are not twice as expensive for no reason. That's ridiculous. Is that the industrial cost as well? Like, doesn't that, because that would, like, if that's the actual cost, that just means you don't get data centers in the UK. Just like enjoy having zero hardware deployed whatsoever in the country. That's so dumb. I was expecting it to be like 20 or 30% higher. This is ridiculous. Yeah, you're more than welcome in America. Now you got beans on toast there. We've got Southern barbecue here. Legal visa is actually super hard. Yeah. For some reason, nobody seems to be able to get that right. It's not hard. It's like if you're doing cutting edge AI. I don't know. Stupid. Ridiculous. Alright, why the fuck does this not work? Can I just, like... What happens if I delete this? Wait, this is literally CPU memory. Yeah. The to be fair, Jess, the visas at the moment are kind of self-defeating. Um, for some reason, it seems like some of the visa program is designed such that it's like get rid of visa holders as quickly as possible, which is the exact opposite of what you want. I don't know. We got a bunch of old and crusty bureaucrats. What can you do? not. Drivers are fine. Problems can often. Yeah. This is driving me crazy. What the? We didn't have this as a problem before, did we? Actually, you know, I'm suspicious. Hang on. Hang on, I'm actually suspicious. What if it ends up being this? I'm gonna feel really stupid, right? Okay, fine. Let's go check. Literally, the bug was, that's so obnoxious. That's so obnoxious. Alright, let's see what we're looking at. Actually, I need to go get my last bit of coffee after that. That's a pain. Literally, the freaking sanitizer flag was somehow breaking the Alex. That's annoying. I'll be right back. Milk. Ugh. The heck is this? Nah, there's something wrong with this indexing. Because you know why? Test it like this. That'll eliminate GDB from the equation. Big fault. Are we fast yet? Nah. Working on being fast. What? Is he running freaking Omarchi? Ridiculous. That's funny. Initiated. Wait, worker waiting on wake. Finish creating M's. Okay. Back receive. Obs on GPU. And then we seg fault somehow. Oh. Duh. Because, obviously we seg fault there, right? This. There we go. Alright, so we have 8 workers. And we have 4 threads. Because you have 2 buffers, you dummy. Okay. Stupid. Okay, so your 4 workers go through correctly here, right? Okay, so after 2 buffers, you break on the first time around, and you are stuck waiting on CPU. Let's go check what's happening here. Also need a drink. Oh yeah, I didn't bet do Diablo while I wasn't looking. Waiting for obs on CPU. Waiting on CPU obs, right. So it's waiting for this flag to get set. And when's this one get set? This one gets set. Obs ready on CPU. Let's do for buffer. Buffer. Or was it buff? Have any emails? No, we do not have emails. Okay, it got farther this time, so it's definitely race condition. So we got buffer 0, buffer 1, so we just have to look through this logic then. Fine. Yeah, that's fine. Almost there. More bugs. Completed is greater than. You also need to just do this. Cool. Okay. That does not. Hang on. No way that I have this fixed, right? Okay, I guess we'll test this first, and then we'll see if there is a race condition afterwards. Alright, so... Did I recompile the right thing? No, I didn't. Dummy. Hmm. Okay, so we have our first identified race condition here. Let's see. Do we have any evidence though? Completed is 16. Back receive is waiting on CPU obs. Why would that be the case? Buffer 1. Let's see, how many of these are ready? We decided buffer 1 obs are ready. Ew. Wait. Yeah, this is why. Hang on. Yeah, because the blocks can finish out of order. Okay. I think I know why it's broken. Now I just have to figure out how to fix it. You can skip blocks, I think. You can skip blocks even if you don't have too many. We should just enforce that blocks finish in order. Will this do it? I think so. Oh. You still break somehow. Did we get them in order? We got buffer 0 obs ready on CPU. Huh? Wait, so buffer 0 obs are ready. Buffer 0 obs are ready. That should not be possible, right? Done. Two buffers. Buffer 0. Buffer 0. That should be impossible right there, no? Done. Buff. You dummy. And I have tabs in here. Ugh. So far, so good. Would your advice be approaching improving technical skills, history, research, engineering, RL? Honestly, landed one, but the interviews were mostly theory. Worried about technical jobs. It depends on if it's LLMRL or anything but LLMRL. Yeah, my articles, I was about to go there. So that is really like all my best advice in one place. You can work through that content quite well, and that will put you in a very good spot overall. I mean, it's mostly like RL when done badly is one of the most painful, horrendous things to work on ever. Um, there's a reason I put so much emphasis on speed and simplicity in Puffer. It yields great dividends. I've seen like many RL teams where stuff is bloated and slow, and it's just impossible to get anything done, and it feels awful, and there's no amount of technical savvy that will save that. So it's mostly about keeping stuff fast and simple, and then obviously, yeah, there is some additional stuff to that, but I guess it depends how much of the theory side stuff was like the old basics versus practical stuff. You can look at some of the advancements we've made in Puffer 3, honestly, as like the actual practical what works. Sort of a mix, VLM, VLA, physics sims. Oh, geez, yeah, robotics is, well, the good news is your understanding of RL, their understanding of RL at the frontier of robotics is also super far off. Honestly, the main thing that robotics people need to do is make their sims faster and faster and easier to debug. For libms for robotics. Yeah. I mean, the thing is, you can totally do your own standalone physics M's, and that's probably on the Eng side one of the better ways to learn. For the most part, nobody understands anything on the like algorithm side of RL. Like most of the fancy algorithms out there for RL just don't work. They're just wrong. So if people are telling you like, "Oh yeah, you don't understand RL, you need to go learn. You need to know the fundamentals of DDPG and QMIC, and you need to know what other bullshit algorithms are there. Gale's imitation. I don't know. There are like dozens and dozens of these like bullshit algorithms that don't actually work. The vast majority of RL is like on policy RL works. Keeping RL more on policy is better. There are some small modifications you can make to existing algorithms that improve even further. We have some of these already and a few more of these planned. There are still some unsolved problems on the algorithm side, but like none of the proposed fancy methods actually address them correctly. And they're all doomed to fail from the start anyways because they're too slow to even test to see if their results are valid. Like the majority of what makes yeah, there is some theory, and if you can understand all of the stuff in my guide, all those resources, you kind of have enough of that knowledge. And then the vast majority of it is Eng. It really is. Okay, so we are still halting here. Go look how this worked. Buffer 0, buffer 1. Buffer 0, buffer 1. Buffer 0, buffer 1. 48. 1, then buffer 0. Cool. So the workers, let's see what the last messages we got. There's some of these that can be out of order and some of them that can't be. Particles.puffer3 codebase and write physics sims. Yeah, that's probably the best way to go. There's some cool low-level engine Puffer 4, but like, as you can see, there is still quite a bit of work left on that. Puffer 4 is going to be awesome, but it is a huge amount of work. And if your company requires Puffer services, we do offer those as well. I gotta mention it, obviously. We're not specialized to robotics or anything, but we do have some pretty good general purpose RL. Any papers? Intellect 3. I have not read that. Oh, this is Prime? Like, why would I read this? This is, like, completely not the domain. Like, this is not RL, dude. Like, LLM RL really is not RL. Like, literally, all the language model stuff, it's just stupid baby mode RL. They can't even train a value function. Like, the things that make what I do hard are completely different from the things that make LLMRL hard. And frankly, the only thing that makes our LLMRL hard is, like, scaling big nets to train distributed is very hard. And then the fact that you can't run any bloody experiments because everything is so expensive is hard. In, like, the style of RL I do, we have making small models fast is hard, making environments fast is hard, making, like, multi-threaded vectorization backends is hard. We have core algorithmic problems on, like, real RL algorithms that are hard. We need, like, we have really large-scale hyperparameter stuff to do, which is hard. There are tons and tons and tons of things. Our FBR, there is no way that forward Euler is what you want for higher dim control. You need to show me a human hand or a humanoid, like something with like 20 degrees of freedom, and then you need to show me consistent energy plots with forward Euler before I will believe that. There's no way. When I say that robotics people are trolling on Sims and like they can do stuff faster, I don't mean that. Keep RK4. Okay, workers waiting on wake. So all the workers are here, so they have not gotten a signal. All right. So actions are ready on CPU. What input sources? Analogy. Honestly, at this point, the path forward is pretty clear to me. I read some amount of research, just not very much, because there are very, very few things worth reading. I have a couple like algo side things that I know are gonna go in Puffer 5. And then for the most part, it's like me just doing fundamental, like the GPU goes this fast, the models go this fast. These two numbers are very different. Why is that the case? And like going through and finding every possible thing. Sometimes that leads me to architecture stuff, like Mingru, for instance. Puffer 3 was a combination of like a few different techniques, extensively validated. I don't know, I don't really need that many sources anymore. It's kind of like everything is sort of just laid out in front of me and I just need to do it. At least at this point in time. I kind of just like think in my head like, okay, what are the main barriers holding back RL? And like, what do I do about them? Tower climb, awesome, Kyung. I will get... Let me... One more thing to check, and then yes, we will do both of those PRs merge. Freaking thing driving me nuts. I just want to figure out why this is stalling here, because I fixed a lot of it. Buffer PR feedback. Of course. If you PR physics ends, I will gladly review those and merge live on stream. Obviously, for closed source stuff from companies, that's another story. That's what we do professionally. But everything that's open source around Puffer is, yeah. Well, chill. Double check one text message as well. Where'd this go? Okay, good. Just making sure. There's one client thing I might have had to have done. We're good. PR something already. You've done a dozen projects and no PRs. I'm once again asking you to finish a project before starting a new one. I just want to fix this last, if I can figure out this race condition, then we can just go and merge Kyung's 2 PRs. We'll look at the sweep stuff, we'll look at tower climb MF PR, and we will be set for today. And I will be on, for folks watching, I will be streaming all day tomorrow. We will see whether it is this or Tiny Grad stuff. FB no PR. Well, he's done like a bajillion M's, but he won't like finish any of them as a standalone. I've seen several of those, like, got 80% of the way there on a lot of them, and just didn't, you know. Actions are ready on CPU. Wait, buffer 0 actions. Wait, it says both of these are ready, right? And then this broadcasts the wait condition. Good small M between Breakout and Tetris. Well, we have Neural MMO 3 is, unless you're gonna like tell me that you have a network that's Rex Neural MMO 3, man. The one thing I noticed, Kyung, that I think is probably very, very suboptimal, Neural MMO 3, for whatever reason, has an absolutely insane gamma coefficient that like sweeps would always return. So I wouldn't be surprised if it's possible to do way better than we have now, but something's screwy. That's on the high end. What is? Oh, Neural MMO, yeah. A good small end between Breakout and Tetris, I see. I mean, you actually making these M's, like, you know, having these M's be a variety of difficulties and, like, actually benchmarking them super helpful. Like, you weren't here when I showed this before. Here. This is literally with a flat encoder. So there's not too big of a gap almost between flat encoder and our conv encoder here, even though the flat encoder doesn't make any sense because we have categorical data in there. You know. I'm confused as to how this thing is blocked. Well, now it's doing the entire thing without getting stuck anywhere. Yeah, it's no longer doing it. Kind of awkward. Any other optimization? Cool. This is annoying because I know that we didn't get all the we did not get all of the race conditions out of here. Okay, there you go. So it does rarely, albeit, it does get stuck. We do get action ready. End index is 2. Okay, so how does this happen? Back in 15? Alright, we'll merge this in 15 as soon as you're back, Young. That way I have time before dinner. Good growth on this. Funny. Is it end index only? Yeah. So wait, I'm end index. Actions ready. Ready. Actions are ready on CPU. 84 and 92 ready. Wait. Plus 8. Another 8. You have actions ready for both of these. These should have broadcasted the end index is 1992. Oh. Oh. I think I see it. I misunderstood how the broadcast works. Let me check this and then I'll explain. I see. There are no ops if no one is waiting. Yeah. So the fix for this... I think this is still a possible race condition, but a way rarer one. No? We still hit it, apparently. Okay. Let me go think about this. So I think what's happening basically is you're losing this broadcast because the thread's still going. So it's not actually updating it's not actually updating and running this loop for long enough. What we can do yeah, so we want to load, hang on, work index. Is this right? X. Can I do this? Maybe? Tiny grit work. So far, so good. What is grit? I'm probably doing more of it either tomorrow or Monday on stream. You still get seg faults. We're waiting on wake. Interesting. Oh wait, atomic load. What the heck is this? Comment all the printfs. That'll tell us if it actually hangs. Oops. Nerd sniped by rabbit holes. Yeah, you gotta not do that. Generally. No more, yeah, no more hanging. Fuel. How do you stop digging into rabbit holes? You have a good mental model of like what's likely to yield progress and what isn't. Made some good progress on this. You commit all this in a minute or two. We might even be able to get to do tiny grad stuff tomorrow. Progress. Failed to evaluate. Select. Mention 1. Think. I goes up to buffers are yeah, this is wrong. Fine. Getting to the point where I'm too tired to keep making progress on this for the day, but I think we can get this to run and then merge Kung's PR, and we're in a really good spot for the weekend. Hey, it runs. And it even trains. Look at that. It even trains. Perfect. Let us commit everything. Buffered vec. Lovely. All right, we're set. See this? We are well set. And I don't need to do any more of this dev on this box. So I can give this one to Jess. So do that. I just need to go grab his. Need to go grab his agreement. There. And then we will review in one moment. We will review Kyung's PR for hyperpram sweeps, as well as tower climb. Back any moment as well. There we are. And I have to send him the tail scale invite. Cool. And Kyung is back, it looks like. How's hyperparameter sweep work? Does it take a lot of time to check all combinations? It does not check all combinations. It does something much more sophisticated than that. Checking all combinations would be a grid search, which is about the stupidest thing you can possibly do. We use protein, which is our own algorithm. You can read about it on X in my articles tab. And then Kyung has made a bunch of optimizations that like prune off bad runs from it as well. What we're going to be looking at right now. Go to puffers. Oh yeah, this entire environment is meant as a reminder to star the pufferfish. Star the repo. Helps a lot. Puffers like stars. Which one first? We do was it 280? Oh, what the heck? Which PR was it? We got 431 and 425. Okay, so early stopping done in 3 phases. No thresholding during min cost. Quantile based thresholding. Threshold increases as cost increases. Hard zone upper bound should exceed the max score so far or it gets stopped. Should exceed the max score so far or it gets stopped. Which is the smoothing thing. This is very vulnerable to noise still, but way better than before. I've seen this. I thought you'd edited it. Maybe I'm dumb. Oh, I'm dumb. Absolutely. Make that account. And Jess, are you ready for multi-GPU sweeps or no? Or, I mean, not multi-GPU. Well, yeah, multi-GPU sweeps or no. I guess you are either way because you can use the 4.0 based stuff. Which does multiple, you know. I'll send you the creds to this. Do not break this machine. There you go. There are your creds. I will let you do some sweeps and some experiments on this for a bit. And then expect that at some point we will move you to an individual box for like more common experiments. because at some point I am going to start needing to use these for constellation sweeps in the next few weeks. The big ones. Lowered the threshold from 1.05 max score to 0.9 max. Okay, perfect. More long runs. Cost normalization is done with mp.quantile. Cost normalization is done with okay. I'm gonna let it sit automatically. Percentile based target metric. Logic transform incoming percentile stores. Yeah, that's not terrible. Later. Chat tonight and get some. Thank you. Sounds good, Jess. I will be around. Can probably join a call if need be later. After dinner. Let's see what we got. Okay. I'm not gonna block this PR on this Kyung, so I'm gonna merge this. But can you please fix threshold to threshold? Let's see. Did you leave that in for me intentionally so I'd have something to nitpick you on? It's spelled Treshol. There's no H here. What? Like, you're missing the H on all of them. No big deal. So, Kyung, can you explain? So this here, is this just that the early runs got to be, like, too long? Like, the default run is just too long or something? Because I see that these are all the early runs being bad. Alright. That's a lot of early run. Like, that's a lot of wasted compute on Tetris, but I'm also getting concerned that if you're only testing on a few M's, you're going to be overfitting this to a few M's anyways. So, you're going to expect to be bugged a whole bunch when I go to run constellation sweeps if things are jank. Oh. Very good. Very, very good. Over 0.9. Jesus. Look at that. That is solid. Good hyper. Wait. Wait so you can do. Alright, I'll wait for you to do your typo fix. Young is fixing typos. Is there anything interesting on the internet? Likely not. Miss anything? Nope. We're also gonna review tower climb. You should make the Ilya stream a running bet. What? I'll do it I will do it relatively soon, Jess. Pushed. Yay. I should probably look at your code. I'm just quickly going through. Top obs. What's the top obs? Oh, so did leave to go get my PhD. I was just there as an intern. 6-month internship, but still. Candidates are also sent. Change quickly. Young, you're gonna have to help me with this because we're gonna have to run like original protein versus this. But like, well, we're gonna have to do some damn many experiments, I'm sure. I'll lend you boxes. But there's gonna have to be a lot of shit for Constellation, so we make sure that we get it right when we go to run 100,000 experiments. Three. That is the only thing. And it's on me that I didn't, I allowed this on 3.0 in the first place, but still. Tower climb. Bitmap. Already being currently generated and saved 20k maps. What do you mean save 20k maps? Okay, we got hypers. Oh, no. Dude, I hate this shit. I hate this so fucking much. Do not ever do this. I fucking hate engineering this way. It's fine. I'll merge it anyways, cause like I'm just gonna replace it. No biggie. But this type of shit drives me insane. This is how you get just like dog shit callback hell engineering. It obscures what the fuck you're doing. It's just not a good time. Map. Levels. Quick fix. Yeah, that's fine, Kyung. I'll merge it for so that you can run stuff. It's cool, this is fine. Touching end of binding, which is good. And maps. Powerclimb.c. H. Oh, you pretty much did just adjust the form. Okay. That's totally good then. Yeah. So that's fine. Fix all M's. Okay. Thank you, Kyung. It was slow because there's a for loop to fill an individual cell. Just a mem copy. Heh. That's funny. I'm surprised that one got by Spencer. I guess this was one, he wasn't as experienced back when he wrote the original for this. That's super funny. Heh. Cool. So both of these merged. Yeah. Young, the goal here is gonna be that like it's probably gonna take me a little longer than I expect to get to this point because I want to have like solid, stable, fast puffer to run experiments on first. And then I'm gonna have to make sure that the C++ and the Python are giving us the same quality results. But then the goal is gonna essentially be that we have like thousands of experiments, full Pareto front across cost and score and steps for all of the environments. And then we probably, the goal is that we run like 100,000 experiments or something ridiculous. I don't know if we'll do 100K or we'll do it based on data. We're going to do some ridiculous number, and then we're going to ship that as a data set, and the Pareto points in there, at the least the Pareto points, if not all of them, are just going to be shipped to the website, and you can play around with them in Constellation. That's the goal. And should give good score metrics. What do you mean M should give good score metrics? That's funny. That's hilariously bad. That's like hilariously. Oh wait, R&D. Hang on. I don't know what this is. Oh wait, never mind. I'm dumb. I actually don't know what this is. Whatever. No, definitely HOTS definitely is not that, my guy. So far, I've been having a good time with TinyGrad. I mean, if it actually solves the problems he says, I gotta order another server from them. Got a principal. M should be research grade to begin with. So I think that we shouldn't have all of the research M's having like multi-component reward functions that also need those tuned. Kyung, like ideally. Like, what do you mean by research grade, right? Like, obviously they should be fast. We definitely want the score metrics, or like a normalized perf metric is pretty much what you want. Like, you need a normalized perf metric for sure. You can use a whole bunch of these. Sweet broke the record by 10x. Well, if the env is easy, if you just solve the env, right? Not every env is going to be hard. Like, you don't need to go in and do things to make the M's harder all the time. Like, for instance, right? Like, people do shit like sticky actions and, like, what else do they do? There's, like, a whole set of wrappers that people apply to Breakout that make it, like, it basically makes it way harder than you look, and that's a bad, than it looks, and that's a bad thing, because you look at the task and it looks pretty easy, and then it's, like, hard for the RL, so you think the RL is bad. Like, this task, I think it's fine to be the way it is, and, like, we just solve it. And it's actually kind of good to have some of the tasks be static so that we can track progress over versions. Because when the M's change, we kind of lose our reference point. So, like, for Breakout, for instance, I'd very much like to keep Breakout the same so that I can track from version to version, you know, how many seconds does it take us to solve Breakout. I think the same with Neural MMO for now, since Neural MMO is the really hard measure task. I kind of want to see, like, over time progress. We can make some architecture changes and stuff, but I don't want to, like, do anything that's going to make the env easier. Right? Most everything else, I think, is up for grabs. Because, like, if you're going to make Neural like, there shouldn't not... I don't think there's a reason to try to make Neural MMO harder either, because, like, we should just make Neural MMO 4 once you get a policy that does everything in Neural MMO 3. What else do I use? I use Drone occasionally. I like Snake as a quick multi-agent test. I use, like, MOBA is actually too easy now. MOBA should be a self-play env. Slime Volley is a self-play env. I mean, I run sweeps on pretty much everything. It's just a lot of them are quite easy, but it's okay to have a good number of easy envs, right? Like, if we have 10 environments that we just have to run, like, a relatively small sweep on to get a really good policy, then, like, we'll know that something is seriously wrong, right? If we haven't changed the env in a long time and suddenly one of them stops working. I thought about that FBR. I'm pretty sure Neural MMO3 would just be slower in CUDA straight up. You're literally just like, it's branching hell. It's a game. It's a full game. I'm pretty sure there's no reason to do that. I think we're gonna see the bandwidth optimization, but I think that it's gonna just be super fast with this new Vec backend. We'll time that maybe tomorrow. So yeah, Kyung, at least there you have like my mindset for this. I want to have a variety of tasks that cover very easy to very hard, and it's good to do work to like optimize towards that. But it's also fine to like, as long as the ends are stable, it's okay to have users just submit a ton of ends, as long as we can use them consistently, right? And then we can just like track and aggregate data across M's, because we can do cool stuff with that, right? We can check like hyperparameter stable region across M's. You know, there's lots of stuff we're going to be able to do in Constellation with the data from more M's. And with that, I have to go get dinner. I got dinner with my family to go to. So for everybody watching, thank you for tuning in. I will be live all day tomorrow, Saturday, and I will be doing possibly Tinygrad stuff, possibly more Vex stuff, possibly both. We shall see. Once again, if you're interested in my content, my work generally, just take a second to star the GitHub. It doesn't cost anything. It really, really does help, and it's, you know, star the puffer, feed the puffer, star. Discord is where all the dev happens. This is where you want to be if you want to learn. Discord.gg/puffer. And other than that, my articles on X are the best place to get started for learning RL. It's all free. It points you to everything that is free. And we also have like some of my research articles are on here as well. So if you want like the latest in cutting edge research, like this was literally the result of a 1 month research block that I did, and it's just here as a quick easy read on X. That's all. Thank you, folks. Enjoy your Friday.